Okay, thank you for joining the lesson. So this is the third lecture about the algebraic identities. Yes? So today I want to talk about a new identity for you. So this is the identity that I want to introduce. Of course, this is not a very hard thing, but I want you to memorize them or try to work with them. Yes? We have this for all. This upside down A means for all, yes? For all A, B, and C in the real numbers belonging to real numbers, we have this new identity. A plus B plus C to the 2 is A squared plus B squared plus C squared plus 2 times A times B plus 2 times B times C plus 2 times C times A. Yes? So that is the new identity. So you remember, the quadratic rule was useful when we want to raise a binomial to the power of 2. Here we have a trinomial, so I have 3 terms added together and I want to square it. So this is the new identity that I want you to at least get familiar with. Yes? Okay, so the first thing that when I introduce an identity, the first thing that I need to do is to prove it for you. But proving this is very simple. So how do you guess that I will start proving this identity? Yes? Yes, I can use quadratic formula, yes? Or we can just simply multiply them. So let us use, because this is the lecture for identities, let us use identities as much as possible, yes? Okay, so if I want to use the quadratic rule to prove this, so I would say that A plus B plus C to the 2 can be considered as A plus B, do you remember? A plus B, I can consider it as one term, and then I have plus C to the 2, yes? This is the first thing. And then A plus B, I will consider it as one single term, and then C as another term. So I have 2 terms added together, then I want to add them, and I want to square it. So I use the quadratic rule. The quadratic rule tells me that you need to square the first one, which is this one, plus 2 times the first one times the second one, plus the second one squared. So this is the quadratic rule, yes? And then there is another quadratic rule happening here, yes? So what is the answer again? The first one to the 2 plus 2 times the first one times the second one plus the second one to the 2. And then here I don't have any identities, I just simply multiply 2 and C inside the brackets, so it becomes 2AC plus 2BC, and then finally I have C squared. And actually I have been able to show it, yes? Because I can write it in this form. A squared plus B squared plus C squared. I can write them next to each other. And then you see that I have 2A times B. And then I have 2B times C. Then I have 2C times A, or A times C. So that is actually the proof for this. Any questions? Okay. Let me give you an immediate example before going further. Okay, example. Now I want you to use this identity. So the identity is this. So the example is this. As you want to expand this, for example, x squared minus 2x minus 3 squared. Okay, can this identity be helpful here? Yes, because I have 3 terms added together and I want to square them, yes? So in principle, this is helpful if I want to use them. Of course, it doesn't mean that if you have forgotten the formula, you cannot solve it, yes? You still can solve it using the quadratic pattern exactly as I have done here. But for more advanced and harder problems, it is better at least to have this pattern somewhere in your head, okay? So if I want to raise it to power 2, this tells me that I need to square each one of terms individually and add them together. But I will have also 2 times the first one times the second one, 2 times the second one times the third one, 2 times the first one times the third one. So all of them I can do. So let me just calculate that. So the answer is the first one to the power of 2 is x to the 4. The second one to the power of 2, positive or negative? Positive. Even though this is negative, but by squaring it becomes positive. So it becomes 4x squared. The last one to the power of 2 becomes positive 9 for the same reason. But then I have 2 times the first one times the second one. Will it be positive or negative?
Negative.
Negative. So it becomes how much? 2 times the first one times the second one. You can do it in your head. What is the coefficient? It's minus 4x cubed, yes? And then I have 2 times the first one times the last one. Again, positive or negative? Negative. So it becomes negative 6x squared. And then I have 2 times the middle one times the last one. Positive or negative?
Positive.
This time positive, because both of them are negative, yes? So 2 times the first one is negative 4x, but when I multiply it by the last one, it becomes positive 12x. Yes? Is that understandable? But of course, it might happen that you can still go further. Yes? In this case, you can go. For example, 4x squared and minus 6x squared are similar terms. So I can combine them together. So what would be the answer? The answer would be x to the 4 minus 4x cubed. Then 4x squared minus 6x squared is minus 2x squared. Yes? And then I have 12x. And finally, I will have 9. So this is the simplified version of that expansion. Do you agree with me? Yes?
Yeah.
So I will not give you more examples of this type because they are very trivial, yes? So you can just use the formula and expand. Okay. So one thing that I want you to realize is that I would write the corollary. And these are the terminologies it's good to know. Corollary is a consequence that immediately happens after a theorem. So when I write corollary, so it means that I am concluding something immediately after my theorem. So the corollary is that if you see here a squared plus b squared plus c squared is equal to, I want to move these 3 terms to the left hand side, okay? So this is already there, so it is a plus b plus c to the 2. Then I move these terms to the left, it becomes negative 2ab, negative 2bc, and negative 2ca. But all of them share a factor of 2, so I can factor it out. So it becomes negative 2ab plus bc plus ca. Yes? So this is also good to remember. Not memorize, because this is enough to memorize, but you can immediately understand that yourself. Yes? So if I want to compare it with what we had before, do you remember? We had a squared plus what? B squared. Do you remember what was the rule? We solved a lot of problems using that. Yes?
A plus b squared minus 2ab.
So it was a plus b squared minus 2ab, yes? Now, this is what we had from the previous session, but now this is something for 3 numbers, yes? But of course, what we need to subtract is a little bit more complicated. Yes? Is that clear? Okay, so let me give you some more interesting examples. So example, if a plus b plus c is 5, a squared b plus b squared plus c squared is 30, determine AB plus BC plus CA. Okay, let me write one more thing. So if you have finished, you don't need to, you can continue. So example, This is a little bit harder one. If x plus y plus z is equal to 0, x squared plus y squared plus z squared is equal to 1, I want you to calculate x to the 4 plus y to the 4 plus z to the 4. Okay, so I cannot wait so much because I need to cover some material today. But can you help me to solve the first one? I think the first one is very easy. Any opinion about that? Yes, Alex?
Just substitute whenever we find that factor,
You mean in this corollary, yes? Yeah. So a plus b plus c is given. A squared plus b squared plus c squared is also given. By the way, how many pieces of information have been provided for you in this problem so far?
2.
2, yes? But the question is involved with 3 unknowns, yes? So this means that this is not a very standard problem. So you cannot try to solve for A, B, and C and find them and then put them here in principle, yes? So you need to use some non-standard way, and then you need to recall this, okay? If you remember that this identity will connect this expression and that expression, that I will consider a simple problem, yes? So how can we solve the problem now? So as Alex actually told, so I will use this identity. So I have a squared plus b squared plus c squared is a plus b plus c to the 2 minus 2ab plus bc plus ca, yes? Okay, a squared plus b squared plus c squared is given directly in the problem, so I can just replace this with 30. On the right hand side, a plus b plus c is also given to be 5, but I have to square it, so it becomes 5 to the 2, and then minus 2 times, this is my question mark, yes? This is my question mark. So this is ab plus bc plus ca. And I think this is a very simple calculation, yes? Okay, so what is the answer? So then it becomes 30 is equal to 25 minus 2 times my question mark. Yes, I'm looking for the question mark, so I bring it to the left, so it becomes positive 2 times the question mark. It's equal to 25 minus 30. And then 2 times the question mark is equal to negative 5, and then the question mark is negative 5 divided by 2. Yes? Is that understandable? But the next one is a little bit challenging. Instead of giving you a lot of time to think about that, let us think together. So I want to hear from you. What is your strategy to tackle this problem? Yes?
You rewrite what we're trying to determine as x to the power of 2 to the power of 2 plus 1
Yes.
to the power of 2 to the power of 2 plus z to the power of 2 to the power of 2.
And then?
We solve it as usual.
So let us follow his strategy. Okay, so he is telling that, okay, my question mark is this expression, yes? So he is telling that, let us write it in this form. X to the 4 plus y to the 4 plus z to the 4 can be viewed as x to the 2 to the 2 plus y to the 2 to the 2 plus z to the 2 again squared. So, yes, this is what you mean, yes?
Yeah.
Okay, and then what?
And then we recognize that it's the same pattern as in the Corollary.
Yes, it's here. Yes, the only thing that has happened is that A in that corollary has been replaced by x squared, B in that corollary has been replaced by y squared, and C has been replaced by z squared. Yes, so I can use the same corollary. If I want to continue, what should I write? Help me to write this down. Someone else? Someone else? What should I write here? Can you read it for me? X squared plus y squared plus z squared, yes, to the 2, yes, minus 2 times x squared y squared plus y squared what? Z squared plus z squared x squared. Agree? Okay, so you see, this is your question mark. I would say this is reasonable. Yes. Why? Because my question mark, which is this expression, is written in terms of two expressions. One of these expressions, x squared plus y squared plus z squared, is provided for me exactly in the problem. So I don't have any problem with the first part. It becomes 1 to the power of 2. Yes? But the problem is that, how do you think about this problem? Someone else? So do you understand what's going on? We use this rule, this corollary, by replacing a with x squared, b with y squared, c with z squared, and I got this. If I want to answer my question mark, I need to know this expression, and I need to know this expression. This expression, I don't have any problem. It's given directly to the problem, that's 1. So I need to do something using the information given in the problem to be able to calculate this one. Now, do you have any suggestions? Yes?
Square the first one, x plus y plus z.
Okay, so do you think that this will help?
Yes.
So I don't want to say no or yes. I can just test your idea here. So you are saying that I square this one. Yes? So what do you mean? You mean that I have x plus y plus z equals to 0. You say that I square both sides, yes? And then if I use the identity itself here, it becomes x squared plus what? Y squared plus z squared plus 2xy plus 2. So let me factor 2 out, yes? So it is 2xy, y, z plus zx. And then 0 to the power of 2 is also 0. And of course you are saying that I know this, which is 1, so I put 1 here. Yes? So what I can find is xy plus yz plus zx. So what is the answer, by the way? Can you tell me what is this question mark? Negative 1/2, yes? So negative 1/2 multiplied by 2 is negative 1, added to 1 becomes 0. So xy plus yz plus zx is negative 1/2. You are right. But this is not exactly that expression yet. I'm not saying that this is useless or useful. If it is going to be useful, you yourself or someone else should manage how to go from here to there. So let us see if this is needed or not. So let me clean this part. So this is what I'm trying to say. This is not that easy in the beginning. You need to train, then you will learn what to do. So what actually Jonathan said gave rise to this expression. It might be useful, but not exactly in this form, because what I need is not exactly is here. Yes? Yes, Lube?
You can substitute that term for xy plus yz plus zx to the power of 2 minus 2xy plus yz plus zx.
So what you are saying that you want to use this fact and then the corollary once more, but now he is saying that I replace A with xy. Okay, and he replaces B with yz and replaces C with zx. Okay, so what you have said is needed, you will see. So this is good. This is not a waste of time. So let me keep it in the box. We will need it. Okay, but now what Luve is saying is that look at this corollary. Replace A with xy, replace B with yz, and replace C with zx. Yes? Because that's a corollary, it means that this is valid for all possible choices of A and B and C. Then you need to be observant and smart to discover the useful pattern yourself. Yes? So let us put these things into this corollary once more and see what happens. Yes? So what happens? A to the 2 becomes x squared y squared plus b to the 2 becomes y squared z squared, and c to the 2 becomes z squared x squared. Agree? Let us see what happens on the right. Can you tell me what happens on the right? A will be replaced by xy, so it becomes xy. B will be replaced by yz, and c will be replaced by zx, and then to the power of 2. Agree? Yes. And then what happens? Be careful here. Minus 2 times a times b. A times b is x, y times z. So what is the answer? X, y squared, z. Exactly. The next one, it's b times c. B times c is y, x, but z squared. So if you don't mind, let me write them in order. Yes, x, y, z squared. And then the last one, ca, this one and this one should be multiplied. I have two x's, so it will give me x squared, y, and z. Yes? So x squared, y, and z. Do you agree? Now, this, I don't have any problem with this part. Jonathan told us how to calculate that part. But then, unfortunately, there is a new problem. So how can I manage the last one? Do you understand what's going on? So, okay. You mean factorization? Yes, that's right. Yes, why not? So let us continue. Instead of this expression, what can I put here? Instead of this expression, we calculated here. So it's minus a half. So let me write it. It's minus a half. So this becomes minus a half to the power of 2. And then, as Sima told, I factorize it. What can I factor out? Can you tell me yourself? Okay, x, y, z. So 2x, y, z. So what is left in the brackets? Y plus z plus x. So if you don't mind, let me write them in order, yes? But we don't have any problem here. The problem is solved, yes? How?
Because 0.
This is 0. This is given directly in the problem. So this one is 0. So then it means that I don't care about the product. I don't need it. So the answer becomes what? 1 to the 4th, and this part is 0. 1 over 4 minus 0. Okay, so now we go back to the question mark. So the question mark, so let me erase this one. Now everything is actually calculated. So the question mark is equal to, so I want to use this here. So the question mark is x squared plus y squared plus z squared. What was the number? What was the number? It was 1. So this becomes 1 to the 2 minus 2 times. What should I replace here? I just calculate. It's 1 over 4. So then it becomes 1 minus a half. So the answer is a half. Yes? So of course this was a little bit more complicated, but you need to get some experience. It is not that hard. If you start playing around with these exercises, I will publish, of course, in exercises. By the video, it's very good to see that. I will put the link for the exercises for every session below the video. Yes? So you can click on it and see the questions. Is that understandable? Okay. So let us change the topic to another identity, which is also very important. Okay, so this is the identity. Again, I want to write it in this form. For this time, I want to raise to power 3, a binomial to power 3. So for all possible values a and b, I have a plus b to the 3 is equal to the first one to the power of 3 plus 3 times the first one to the power of 2 multiplied by the second one plus 3 times the first one multiplied by the second one to the power of 2 plus the second one to the power of 3. I really want you to memorize that. Of course, these are particular cases of a more general theorem called Newton's binomial theorem. I will discuss about this at the end of these lectures of identities. Okay, but before that, let us know them case by case. So quadratic rule was one of these particular cases. The cube of a binomial is also another particular case which is important. Okay, so I really want you to try to memorize them after learning. Okay, So the first thing, of course, would be again the proof, but the proof is so simple, yes? So if I want to prove this, what is your suggestion? A plus b to the power of 3, I want to show that this is indeed correct. So what should I do? To the power of 2, yes? You can speak louder a little bit, thank you. So a plus b, yes? Of course, as you said, I can multiply this 3 times, yes? But let us use identities as much as possible. So then, this is the quadratic rule, so the answer is a squared plus 2ab plus b squared, and then this one is a plus b. So what I do, I start multiplying, because there is no identity here that I can recognize, so I have to multiply. So a squared by a is a cubed, a squared b. This is finished. Next term is 2a squared b plus 2ab squared, and then I have b squared a plus b cubed, yes? And then what happens, I have a cubed here, but a squared b and 2a squared b are similar, so I add them. How many I get? 3. 3a squared b. And then I have this one and that one, they are also similar. ab squared, ab squared. So how many of them will I have? I will have 3 again. So 3ab squared, and then finally I have b cubed. And then you can see that this is exactly what I have written on the right-hand side. Of course, sometimes in the books they write it for 2 different signs, one positive, one negative. But I don't want you to learn it in that way, because there would be too many formulas if you want to memorize them. So can you immediately tell me what will happen if I write a minus b? Yes?
You can write it as a plus negative b.
Yes? And then can you see what would be the consequence of this negative sign in the answer? Yes, as you said.
Brackets, negative
Yes.
b.
So what he's saying is that instead of minus b, so a minus b can be viewed as a plus minus b. And minus b is the second term. So if I put minus b here instead of b, this will give me a negative sign. But what will happen here? Nothing, because minus b to the power of 2, even though negative, it becomes positive. But what will happen here? It becomes negative again, yes? So, yeah, so the books usually write it in 2 different ways, but you really don't need to remember that again. But you see that the signs are alternatingly changing. Yes, so this is, if you want, you can also write it, but you don't need it, okay? Immediately you can find it yourself. Any questions here? So let me give you one very simple example, and then go to more exciting examples. Okay, so example. So I want you to use this identity to expand, not by multiplication. So expand this is very simple. 2x minus 3y squared to the power of 3. So let me make 2x cubed minus 3y squared to the power of 3 using this identity. Don't mind, let us start. So 2x cubed minus 3y squared to the power of 3. So if I want to write all the details, let me do this for the first time. The first one to the power of 2, it should be written in this form. To the power of 3. And then plus 3 times the first one to the power of 2 multiplied by the second one, but the second one contains a negative sign. Yes? And then I have plus 3 times the first one itself multiplied by the second one to the power of 2. And finally, I will have the second one to the power of 3. Can you follow? So I'm just exactly using the pattern, but the second one, I am keeping the sign with it. And then I need to calculate some simple things. So this one to power 3, what's the answer immediately? 8x 9, yes, to the 9. And then here. So first of all, the sign is positive or negative at the end? Negative, yes. Because, so how much is the coefficient?
4.
It's 4, no, this one becomes 4, times 3 is 12, times negative 3 is negative 36. And what is what is the exponent of x? 6. The exponent of y? 2. Agree? So that's the answer. And the next one, positive or negative?
Positive.
Even though it's negative here, but because of this power 2, it becomes positive 9. Positive 9 times 2 is 18, times 3 is 54. And then the exponent of x is x to the 3, and the exponent of y is y to the 4, yes. And finally, the next one, positive or negative?
Negative.
Negative how much? Minus 27, y to the 6. So that is the expansion. Can I simplify this more? No, I don't see any similar terms. So that's the end of the problem. Yes? Okay, but now, again, let me write something corollary.
Why don't we call it theorem rather corollary?
Usually, there are all of them are theorems. The theorem is a true statement. Okay, corollary is also a true statement. I don't know, lemma, proposition, these are the words that mathematicians. But corollary usually means that I have a main theorem, and there is an immediate consequence of that, which worth to remember. So then they call it corollary. Yes. So I want you to see these words. Okay. So the immediate corollary of that is that I want to keep a to the power of 3 and b to the power of 3 together, and I want to move these two terms to the other side by changing the negatives. So what will happen? Can you help me here? So, I will write the corollary here, but before that I want to derive it for you. So this becomes a plus b to the 3 minus 3a squared b minus 3ab squared. What is left on the right hand side is what? A cubed plus b cubed. Yes? So I just move these two terms to the left hand side. And then, when I want to write the formula for the corollary, I write it like that. A3 plus B3 is equal to. I have A plus B to the 3. Okay? And then what can I do between them? I can factor something out. Minus 3 times A times B. Yes? So I factor minus 3AB out. So what is left in the brackets? A plus B. Okay, so this is what I want to write it as a corollary. Again, if you want, you can compare it with what we had in the previous session. Do you remember? We learned that a squared plus b squared is what? Is a plus b to the 2, but minus 2ab, end of the story, yes? But if I have a to the 3 plus b to the 3, it becomes a plus b to the 3 minus 3 times ab times a plus b. Yes, so it's very important. You can calculate this if you have the sum of the variables and if you have the product of the variables. Okay, and usually people call a plus b s for the sum, and a times b p for the product, and then you can immediately see that the two corollaries can be written in this form. I can write that a squared plus b squared is s to the 2 minus 2p, and I can write a to the 3 plus b to the 3 is s cubed minus 3ps. So it means that if I give you the sum of the variables and the product of the variables, in principle you can immediately calculate the sum of the squares, and you can immediately calculate the sum of cubes. Yes? Yes? Is that understandable? So let me give you some examples that we can use this corollary. The type of the problems that you can use this corollary to solve them is very similar to what we had before. So let me give you an example. By the way, if you want, you can change b to negative b. Then it becomes a3 minus b3. This becomes a minus b to the power of 3. If I make it negative b, this becomes positive, this becomes negative. Yes? So you can change b to minus b yourself and just write it for the subtraction. Okay, so let me give you another example. So let x plus y be equal to 2 and xy be minus 1. Okay, so answer these questions. What is x cubed plus y cubed? And then what is x to the 6 plus y to the 6? And what is x to the 9 plus y to the 9? So I think that you have a lot of experience now with these kinds of calculations. But now you have a new identity that can solve this problem a little bit faster. Okay, can you tell me what to do?
X plus y cubed minus 3xy plus x plus y.
So you are using the corollary exactly for the first one. Exactly. But do you remember, could you solve this problem in the previous week?
Yes.
Yes, you could solve it, yes? We solved something like this by giving you the information about x plus y and xy. But then you calculated x squared plus y squared first, if you remember, and then used this trick of multiplying both sides together to generate x cubed plus y cubed. But you don't need to do that here, because now you have a little bit more knowledge, more identities at your disposal, so you can use it and then solve the problem, yes? So x cubed plus y cubed using the corollary can be written as x plus y to the 3 minus 3 times x times y times x plus y, yes? So this is also a new way of solving the problem from the last session. So then everything is given to me. X plus y is 2, so 2 to the 3 minus 3 times xy, which is negative 1. xy is given directly in the problem. And then I have x plus y again is 2. So if I solve this, it becomes 8. And then this is 6, yes? Positive 6. So it becomes 14. So the answer to x cubed plus y cubed is 14. This is fairly simple, yes? But can you tell me how can I calculate x to the 6 plus y to the 6 then?
X plus y cubed or y cubed, and then this square.
No. What do you mean exactly?
X plus y, like x squared, or no, what I'm saying, x cubed plus y cubed, and then you square that.
Okay.
You take minus 2xy, both cubed.
Ah, yes. So you are using another identity from the previous session. That's right. So, I mean, I don't want to restrict you. You can use your own methods. But if I want to solve x to the power of 6 plus y to the power of 6, if I want to use this rule today, so I replace x with x to the power of 2, then it will generate x to the power of 6 for me. Yes. So, for example, so let me write the corollary here for you. This was a plus b to the 3 minus 3ab times a plus b. So if I replace a with x squared, if I replace b with y squared, then what will happen? This will give me x to the power of 6, which is exactly what I want. And then the second one will give me y to the 6, which is also exactly what I want. But on the right-hand side, unfortunately, I will get x squared plus y squared. Probably we can solve it somehow to the power of 3. And then I have minus 3x squared y squared. Then I have x squared plus y squared. This is one way of writing. There is also another way of writing, yes? Instead of using this corollary and these substitutions, can you think about another one? Yes, Lube?
x3 plus y3 power of 2.
Yeah, from the previous one. So you can solve it in this way. You can consider this formula, which is a plus b to the 2 minus 2ab. Yes, do you remember? This is from the previous session. But this time, I replace a with what? X cubed, and replace b with y cubed. Then what will happen here? This becomes again x to the power of 6 plus y to the power of 6. On the right hand side, I will have x to the power of 3 plus y to the power of 3 to the power of 2 minus 2 times x to the power of 3 y to the power of 3. Okay? Of course, both of them are manageable. But which one is better for this in this context? The second method or the first method? The second method, yes. The second method is much more useful because I have x to the 3 plus y to the 3, and I just calculated that here. Okay? If I want to use this for solving this, it is possible. But first, I need to calculate x squared plus y squared, what we learned before, and then after that, I can calculate this. Okay. Now, let me continue. So, I will take this one. This is better. So what is the answer now? X to the power of 3 plus y to the power of 3, I just got it 14. So this becomes 14 to the power of 2. But what can I write instead of x cubed, y cubed?
xy cubed.
Xy cubed, yes? Xy cubed. And then what is xy? Xy is given directly in the problem, it's negative 1. So negative 1 to the power of 3. So it becomes minus 2 times negative 1 to the power of 3. And then this is a simple calculation. This to the power of 2 is 196. Minus 1 to the power of 3, negative 1, multiplied by negative 2 is positive 2. So the answer is 198. Now I think every one of you can see what can I do for the last question mark, yes? So what is the most suitable choice for calculating x9? Yes, Sam?
Instead of doing instead of squaring it, just cube it.
So where you mean?
In the
Here.
No, in the second method.
Instead of squaring it, cubing it, yes? Okay, so what you mean is actually this one. Yes, yeah, you're right. So let us, for solving the last part of the problem, I use this corollary, but I replace a with x cubed, and I replace b with y cubed. Yes? And then this becomes x to the power of 9 plus y to the power of 9, which is my question mark. And then this becomes x to the power of 3, y to the power of 3. Everything becomes to the power of 3, yes? Agree? And then what I do is I have everything now ready. So I leave the calculation. So this x to the power of 3 plus y to the power of 3 has been calculated to be 14. So this becomes 14 to the power of 3 minus 3 x. This is exactly xy cubed, which is minus 1 to the power of 3 times 14. And you calculate this number and you get your answer. Yes? Is that clear? Okay, so what I want to teach you is another pair of identities. They are also very important. You always see them in the formula sheet, but you usually probably don't use it so much. So another identity that I want to talk about is that for all possible choices of A and B in R, the set of real numbers, I have A plus B multiplied by A squared minus AB plus B squared. So this, you need to remember this pattern. I have A and B added together, multiplied by this combination. The answer becomes A to the 3 plus B to the 3. Okay? And usually, let me write it in pairs. Let me switch B with minus B's. So it's A minus B. Then this will not be affected. This becomes positive AB. This becomes again positive B squared. But on the right hand side it becomes A to the 3 minus B to the 3. So you see, I have a binomial multiplied by a trinomial. So, but the trinomial has a particular form, not any trinomial. The trinomial should consist of the first one and the second one squared, and the product of them with opposite sign. If this is positive, it should be negative. And if it is negative, it should be positive. In that case, if you want to answer it, you can raise the first one to the power of 3, raise the second one to the power of 3. If this is positive, you put positive. If this is negative, you put negative. Okay? You might say that, okay, why I need this formula? This formula, I don't know, this a to the power of 3 plus b to the power of 3 has two formulas now for us. This one and this one. But I don't know, can you see what is the benefit of writing it in this form over that form?
Easier to remember.
Pardon?
Easier to remember maybe.
No.
If the data is given, then you can.
No, there is a main difference between this way of writing a cubed plus b cubed and that way of writing a cubed plus b cubed. Yes, Sam, do you want to say something?
Maybe it's that is easier to find, you know. Maybe the variables are easier to find.
No, there is a main difference. Yes?
The second one contains the quadratic formula.
No?
Is it less terms?
No? Probably all of them are correct, but that is not what I mean. Yes? What I mean is that here, this is a factorization of a3 plus b3. Yes? a3 plus b3 is written as a product. In the future, when we want to talk about factorization, if I ask you factorize a3 plus b3 and you write this for me, even though this equality is right, but that is not a factorization because this is not a product of terms. Yes? But here, these two terms, these two expressions are multiplied together to give me a to the power of 3 plus b to the power of 3. So for example, in the future lessons, if I ask you to factorize this, you need to remember this and factorize it. Yes? For example, if I ask you factorize this, you can do that. But do you remember, for a squared plus b squared, I cannot factorize it in real numbers. But if I ask you factorize a squared minus b squared, you can factorize it. What is that? The conjugate pattern. A minus b, a plus b. So this is very important to remember. In the future that we want to talk about factorizing expressions, if you want to factorize the sum of cubes or the difference of cubes, these are the formulas, not those. Yes? So we will learn them later. Okay. So I want to give you some examples. I think the proof of them are very simple. Yes, you can do it yourself. You can start from the left-hand side, multiply them, simplify them, and you get the right-hand side. So let me just give you some examples. So I want to make sure that you understand this identity very well. So I really want you to try to memorize them after learning them, of course. So if possible, use the above identities to expand. So number 1. So a minus 2, a squared plus 2a plus 4. Do you think that this expression, can I use one of these identities to calculate this immediately? So you need to recognize the pattern yourself, yes? The answer is yes or no?
Yes.
Yes. I have two terms subtracted here, but this is important to realize that this is in the correct form. What is the meaning of the correct form? This should contain the first one squared. Yes, it contains. It should also contain the second one squared. It contains. It should also contain the product with the opposite sign. If I multiply them, it becomes minus 2a. The opposite sign is positive 2a. So everything is based on the second identity here. Yes? So you don't need to expand it. What is the answer? The answer is the first one to the 3 minus the second one to the 3. And then, of course, you can write it as a3 minus 8. So that's the answer. Yes? But the importance of this theorem would be later. I will give you this and I will ask you factorize it. So you need to be able to remember that you can factorize it in this form. Yes? Okay, number 2. So I will write all of them for you. You can think yourself. But we don't have that much time now. Yeah, that's okay. So, do you think that this follows some kind of pattern here? Yes. I have two terms subtracted. The important thing is this one. Does this follow exactly the same pattern that we need? The first one to the power of 2 is here. The second one to the power of 2 is also here. The product of them with the opposite sign is also here. So everything is in order. So what's the answer? It's x to the power of 3 minus the second one to the power of 3, which is 8y cubed, yes? And then the second one is what? This one. Does this follow the pattern? No. The first one squared is here, the second one squared is here, the product of these two is also here, but the sign is the same. So what can I do if I want to answer this? I cannot use these identities, but if I insist to expand it, there is only one way. I have to multiply it. Yes? So, but do you see the pattern here? Yes. The first one to the power of 2, the second one to the power of 2, the product of them with the opposite sign. So what's the answer? The first one to the power of 3 is x6, positive or negative?
Positive.
Positive, because we care about this one. So it becomes plus 8y cubed. Yes? So we have worked 3 or 4 minutes. So let me write this one as well for you. So number 5. So I want you to use identities as much as possible. Okay, please give me your suggestions. We don't have that much time.
Combine first.
The first what?
First, three products have to be combined into one.
Yes, the conjugate rule is a good one. So so I will keep this one. This is a conjugate rule, yes? So let us just do it one by one. So then what happens if I use the conjugate pattern? It becomes the first one to the 2 minus the second one to the 2, yes? And then I have x to the power of 2 plus x to the power of 6 plus x to the power of 4. Okay, any more pattern that you can detect here? Yes?
That if you multiply x to 1 minus x squared, it follows the pattern.
Exactly. So let me follow that. So he's saying that multiply this one only. Okay, so what happens? It becomes x minus x cubed, and then I am this left. Now, do you recognize this pattern now? I have two terms. Let us check that the trinomial has the correct pattern. This one to the power of 2 exists here. This one to the power of 2 also exists here. The product of them, x4 with the opposite sign, is also there. So everything is in order, yes? So what's the answer? The answer is x cubed minus
x to the power of 9.
to the power of 9. Exactly. So you see, if you recognize the patterns, it is much easier to do that. And we have 1 minute, so let me write one more. Then I will provide you with a lot of exercises tonight. Okay? So the last one, number 6. I have x minus 1 to the 3, and then I have x plus 1 to the 3, and I have x squared minus x plus 1 to the 3, x squared plus x plus 1 to the 3. Yes? So since we don't have time, if you don't mind, let me solve the problem. Okay, so what I do, I will take this one. Of course, there are 4 numbers. It doesn't matter how I multiply them. Okay, but if I can see the pattern here, and I contain this one with that one, and I can use these two together. Okay, so let me This is not here. So this one and this one together, these two together. Okay? So what can I write? This has a power 3, this also has a power 3, and this is a product. So I can write x minus 1 times x to the 2 plus x plus 1 totally to power 3. Do you agree with me? Yes, that's a product. And I have power 3 here. And I can do the same thing here. So it becomes x plus 1, x squared minus x plus 1, and I have to the power of 3. Okay, but can you see any pattern here? I have 2 terms and I have 3 terms. Yes, they are multiplied again. I have a square of this one here, a square of the second one here, the product of these 2 numbers with opposite sign here. So that's exactly the pattern. So what would be the answer? It becomes the first one to the 3 minus the second one to the 3, which is 1. And then I have another power of 3 on top of that here. Yes? And then the same pattern here. I have x squared is sitting here, 1 squared is sitting here, the product of them with the opposite sign is also sitting there. So the answer becomes what? X cubed plus 1 to the power of 3. So how should I continue? This is not finished yet because I have still brackets left. Yes, Lube? Loudly?
Factor out to the power of 3 and then use conjugate.
Yes, so exactly. So I would write x3 minus 1, x3 plus 1, and then to the power of 3. Yes? But then this is a conjugate pattern. So what's the answer? X to the 6 minus 1. Yes? And then to the 3. But this is another pattern we learned today. Yes? We want to raise a binomial to power 3. Do you remember what was the rule? The first one to the power of 3? 18. 3 times the first one to the power of 2 multiplied by the second one. 3 times the first one multiplied by the second one squared. And finally the last one cubed. Yes? So this is a nice exercise. Yes? You detect the patterns and then immediately one after the other you are using the rules to be able to expand that one. By the way, I hope that you appreciate this is much, much simpler. If you don't want to do it, if you just blindly want to expand them to power 3, this has 8 terms, 8 terms. This has 27 terms, 27 terms. So 8 times 8 times 27 times 27 is a huge number. But we were able to actually simplify it if we can detect the patterns.